Hi everyone, I'll be continuing sheet 2 and I'm gonna jump to question 3. But before I go to question 3, there's some things I should really recap on because question 3 really depends on it. It's back to calculus 2 and calculus 1. The differential of sine x is cosine x, and the differential of cosine x is minus sine x. These are really important rules that you should really memorize. So you can be able to solve sheet 2, and the opposite is also right. So if the integral of minus sine x is cosine x and the integral of cosine x is sine x, because basically the differential is the opposite of integral. Okay, now once you have this in mind, you will be able to solve question 3. So here we go. Here's question 3. It basically says sine y minus y sine x dot dx plus cosine x plus x cosine y minus y dy all equal to 0. Okay, so the first thing we should be doing, back to the rules. Okay, sorry. You got m and you got n, and the first thing you should be really doing is differentiating m according to y and differentiating n according to x. So let's do this. So the differential of m according to y, alright, so that's sine y, and as you can remember in the earlier rules, sine y simply becomes cosine y. Okay, the rules that I just revised earlier. And then you got y minus y sine x. So basically the y will disappear and you're gonna write down minus sine x. Well, if some of you will ask why didn't we differentiate sine and change it to cosine, that's because it has an x next to it. And in here you're differentiating m according to y, and so that's why you wouldn't turn sine. There's no y here, there's an x. So you'll just remove this part over here. This will turn into a 1, an invisible 1, which we actually don't write. Jumping to the second part, the differential of n over x, or according to x. So you got cosine x, and according to the earlier rules, cosine x simply becomes minus sine x. And then if you look at the second part, you got an x, and this is differentiating with according to x, so the x turns into an invisible 1, so thus you got a cosine y plus. And then you got minus y. Minus y will actually turn into a 0 because we're differentiating with according to x. And guess what? Look what we have. We have cosine y, that's 1. Then you got minus x, minus sine x. And we have just satisfied our rule that the differential of m according to the y and the differential of n according to x equals each other. So let's write this down. Differential of y, differential of n over x are exact equation. Okay, the next step we should be really doing is integrating. So let me just write down the rule. So that will be m xy dx. Guys, just be careful that when you differentiate, you're differentiating according to y, and when you're integrating according to x. So just be careful not to do this mistake. So let's look at m. This is m, and we're gonna integrate it with according to x. Is there an x here? No. So we're just gonna simply add an x. That's it. Is there an x here? Yes, there is an x here. And the integral of minus sine x will turn into, well, I can't really remember, so just go back to my rules that I just wrote earlier, and we got minus sine x, and what do we have here? Minus sine x, so minus sine x will turn into cosine x, or cosine y, yeah, cosine y. So we got minus sine x, it will turn into minus cosine x, and dy will be as it is. Okay, and moving on to the next part. Oh, let's not forget plus c1. Now let's integrate n with according to xy to dy. Let's look here. Cosine x, we're integrating to y. Nope, so just gonna add a y. So that's y dot cosine x, and then we got x. Oh, we got an x. Nope, we're integrating to y, but we got cosine y. Again, I don't really remember what's the integral of cosine y, so I'm just gonna go look back to my rules. Cosine y, cosine, yeah, it's right over here. So if we're integrating, we're going the opposite way, so that will be sine x. So what we have here is a cosine y, that will be a plus sine y with an x, and then you got minus y, so minus y will be minus y to the power of 2 over 2o plus c2, because this is the second part. So you got c2 is to this part, and you got c1 to this part. Now let's clean up this equation. Let's first of all look at which terms are alike. So what do we have here? We have x sine y, we have x sine y, that's for starters. And what else do we have? Did we do a mistake here? This is actually a negative, or is it not? I think we did a mistake here. Let's go look back to my rules. Minus y sine x, and yeah, I'm sorry, this will be positive. So thus we have this part and this part the same. So as I said earlier, if you got parts that are equal to each other, you're just gonna write them once. So now we got x sine y. So we got this out, and then we got y cosine x and y cosine x, so that will be y cosine x. And we have minus half y squared, all equal to c. Yep, we got that right. Okay guys, let me tell you a quick trick, okay? How do you know how many numbers you should equal to each other? Well, first of all, if you differentiate the equation and you get two values, that's first value, this is the second value, and look here, you got the first value and you got the second value, then in this answer you should have two numbers equal to each other, not one. This is just a little trick. Let me go over it again. So if you have the differential and you got two values, so that's a cos y and a minus sine x, and over here minus sine x plus cosine y, then basically you're gonna have two numbers that are equal to each other. Thank you.